Hello friends, Ace Botany next episode. In this episode, we'll be discussing anatomy of flowering plants, fifth one, last part. Secondary thickening not in present syllabus. So this will be the last episode of anatomy of flowering plants. So we can proceed. So I will share the screen, it will be convenient for you. I think screen came, so we can proceed. So anatomy of flowering plants, fifth episode, chapter number 6. And what all things we'll be discussing in this episode? There will be a small introduction regarding the syllabus or topic, what we'll be discussing. Then topics, dicot stem, monocot stem, their section, dicot leaf, monocot leaf, their section. And as usual, 5 theory question, 5 NEET model question with the key. So as an introduction, we'll be dealing the features of dicot stem, dicot leaf, and monocot leaf. So when we study the features, we can easily distinguish the differences also and similarities also. Now, this diagram in the screen, it is typical NCERT diagram dealing with dicot stem TS, monocot stem TS. Figure number 6.4 in NCERT. So that itself is a labeling question. Practical wise can be put. Theory wise, draw a TS of dicot stem, monocot stem, label the parts. Entrance point of view also, there can be questions. So we can now proceed with the dicot stem specifically. I think the screen came dicot stem. So when we proceed with the dicot stem, diagram very clear, NCERT clearly given. So first layer is called epidermis, that is outermost layer. Outermost layer means it will be protective, usually single layer. Cuticle is present. Presence of epidermal appendages that we already studied. Then epidermal structures, typical example is trichomes and stomata. Second part is cortex. So after epidermis, many layers can be seen. That is between epidermis and pericycle. That is the part called cortex, which has got 3 subdivisions, which include 1, hypodermis. So what is the meaning of the term hypodermis? Below, hypo means low, below epidermis. It is the outer area of the cortex. Outermost area is hypodermis, below epidermis, usually 3 to 5 layers. And hypodermis is normally collenchymatous. Dicot stem, hypodermis is collenchymatous. That itself is a question. No gaps. Collenchyma means angles will be thickened. And main function is providing mechanical strength. Again, a typical dicot stem. This is the ground plan or diagrammatic sketch. A part of it is enlarged here. Now we can proceed to under cortex, next part. So after hypodermis, next part is called general cortex. That is below hypodermis and above endodermis. It is mainly made up of the involved parenchyma with intercellular spaces. Shape is probably round. Then comes next layer. It is called endodermis, innermost layer of cortex. Can have starch grain, so it is called starch sheath. Then comes pericycle. So it is below endodermis, but above phloem. When you check the diagram, it is very clear. Pericycle you can find here. So it is below endodermis. Endodermis here. So below endodermis, that is pericycle, and above phloem. So sandwich between endodermis and phloem. Occurs in patches with the semilunar shapes, and it is made up of sclerenchymatous. Then comes vascular bundles. It will be many, consisting of xylem and phloem. Cambium present since it is dicot. In between xylem and phloem, vascular bundles are cojoined, collateral and open. Endark type since it is stem. Vascular bundles are arranged in the form of a ring. Now comes last layer. It is called pith or medulla. Central part of stem. It is parenchymatous. Round, presence of intercellular spaces. Then comes pith rays or medullary rays. These are cells seen between vascular bundles radially placed. Looks like rays, hence the name. Pith rays or medullary rays function is radial conduction. That is regarding dicot stem internal structure. Now we can proceed to monocot stem. So stem, when we compare, that will be almost similar except few differences. So it will be easy for us. So as usual, monocot stem, outermost layer is epidermis, single layer, cuticle present, stomata may be seen. After epidermis, next layer is hypodermis. Here you can find hypodermis. It is clear and matter. So to take section for monocot stem, slightly difficult due to the presence of hard sclerenchyma cells. Function is mechanical support. Remember in dicot, hypodermis is collenchymatous in dicot stem. So it's a usual question, and entrance point of view also a question. Now there is a massive area called ground tissue. It is the main bulk of monocot stem. No much differentiation. Dicot, it is more differentiated. Dicot stem here, differentiation is very less. Below hypodermis, mainly ground tissue consists of parenchyma cells. I think up to that it is clear. Now we can proceed to next page. Next is, as usual, vascular bundles. Diagram very clear. Large number of vascular bundles. Here you can find it. It is placed in a scattered manner in the ground tissue. Size of the vascular bundles small and more towards periphery. It is a popular question. This area you can find vascular bundles are small but more in number, closely arranged, and larger and more freely arranged. Central part, if you check, you can find it is larger and more freely arranged towards the center. So this diagram is important one, just what I told. Outer, smaller and more, inner, larger and few. Since it is monocot stem, cambium absent, vascular bundles normally oval in shape. Each vascular bundle is surrounded by a sheath called bundle sheath, made up of sclerenchyma. No cambium seen, so it is closed. Conjoined, since no cambium, no secondary growth in monocot stem and root normally. Since it is stem, xylem is centered. Presence of water-containing cavities. Yeah, but a white patch is very small still. Presence of white water-containing cavities. It is found by schizo-lysogenous in origin. It's a predominant question, schizo-lysogenous in origin. And these water-containing cavities are often called protoxylem lacuna. And we already studied that in monocot, phloem parenchyma is absent. That is regarding dicot stem and monocot stem. Better compare and proceed. Now comes dicot and monocot leaf. So when we start with the dicot and monocot leaf, generally when we take it, leaves are the main photosynthetic organ in plants. It is usually flat. Leaves has got epidermis, one on upper side and one on lower side of the leaf. Photosynthetic tissue lies between upper and lower epidermis is called mesophyll. Theory question, entrance question. Photosynthetic tissue lies between upper and lower epidermis in a leaf is called mesophyll, main photosynthetic area. I think that page is clear. Now we can observe two NCERT diagrams. Here you can find it is a labeling question, identification question, all this. Then take a draw in NCERT, means a theory question that way. Now both are simultaneously placed on the screen, so it will be easy for you to compare NCERT only. Now we can proceed with the dicot leaf is also called dorsiventral leaf because dorsal side and ventral side are very, very clear. We can easily distinguish both the sides. Monocot leaf is also called isobilateral leaf. Iso means same, bi means two, lateral means so two sides looks alike in monocot leaf. Now we can find here, upper side is otherwise called adaxial or ventral. All are same surface, top side of the leaf. Lower side is called abaxial or dorsal. All are same surface, that is underside of the leaf. Upper adaxial ventral, upper surface of leaf, top side of the leaf. Lower abaxial dorsal, that is underside of the leaf. So the synonym, I think it is clear. Now we can proceed to next aspect. See, dicot leaf generally remains horizontal. So by which sunlight falls on the upper surface in dicot leaf. The ventral and dorsal side are easily distinguishable in dicot leaf. That is why it is called dorsiventral leaf. So leaves generally remains horizontal. Maximum sunlight will be falling on upper surface. In dicot leaf, upper and lower side can be easily distinguishable. That is dorsiventral leaf. Monocot leaf generally remains vertical. Both surface of monocot leaf is almost same. That is why the term isobilateral leaf. Both sides looks alike. Now we can proceed to dicot leaf separately. Otherwise called dorsiventral leaf. Section wise, when we take three parts can be distinguishable. epidermis, mesophyll, vascular system. Epidermis, leaf, presence of upper and lower epidermis, cuticle present, usually single layered, and parenchymatous. Less stomata on upper epidermis, which is otherwise called adaxial epidermis. Maybe even absent in comparison with the lower epidermis. Now, in lower epidermis, we can find more stomata. Just below stomata, there is a substomatal cavity connected with the exchange of gases. Generally, chloroplasts are absent in epidermal cell. Guard cell will have chloroplast. Generally speaking, chloroplast is absent in epidermal cell. Cuticle will be present. Now, mesophyll, the main area, the leaf. Mesophyll is a photosynthetic tissue lies between upper and lower epidermis and leaf. And remember, mesophyll is a part of ground or fundamental tissue system. It is mainly made up of parenchyma, so normally it will be thin walled with the chloroplast, so it is chlorenchyma. And in dicot leaf, for mesophyll, two regions we can easily distinguish. That is how we can distinguish dicot or monocot leaf. Diagram we can find here, one area this one area this one. So upper area, which is otherwise called palisade parenchyma. It is below upper epidermis, that is upper side of the leaf, and it is called adaxial. Adaxial. 1 to 2 layers. Cells are arranged vertically. Here you can find upper side. Cells will be arranged vertically. Cells are elongated. Cells are parallelly placed, having numerous chloroplasts, no intercellular space between cells. Very clear in the diagram. That is palisade. Next is spongy, loosely arranged. Here you can find it. Below palisade tissue, lower part of the mesophyll, that is abaxial, round or oval cell, irregularly placed. Cells have intercellular space, diagram very clear. And air cavities, chloroplast is seen. So mesophyll, two area, palisade and spongy, their characters, features, etc. Now comes vascular tissue system or vascular system. Vascular bundles are scattered in spongy area. Here you can find spongy area. It can be seen on veins and midribs of the leaf. Midribs of the leaf. Venation dicot, it is reticulate. Thickness of the veins will vary. The vascular bundles have no cambium since it is a leaf. So it is closed, conjoined. Vascular bundles are surrounded by thick-walled bundle sheath. There in NCERT, that line is given, page number 77, connected with the figure 6.5a. March 24, reprint edition, that statement is given. Thick-walled bundle sheath. Thick-walled bundle sheath. Here I think spelling somewhat wrong. Thick-walled bundle sheath. Then, that is why I put that star. NCERT only given that statement. Vascular bundles are larger in thicker veins and smaller in thin veins. That means size of the vascular bundle depends on size of the veins. Now comes in leaf, xylem is on the upper side, that is called adaxial, and phloem is on the lower side, that is abaxial. So xylem, adaxial, upper, phloem, abaxial, just like our face. Eyes we can compare with the xylem. Mouth we can compare with the phloem. Under normal arrangement, normal situation. So in leaf, xylem is adaxial, upper. Phloem is abaxial, lower. Is a prominent question. Now comes monocot leaf, which is otherwise called isobilateral leaf. Since leaves have some common features, only certain changes available in monocot leaf, just like dicot stem, dicot root, etc. Here also an epidermis will be there. Presence of upper and lower epidermis, single layer of cells that are common. Stomata present. Number of stomata almost same on both sides. That is why the term isobilateral looks alike. Cuticle present on both sides. Presence of certain large cells in the upper epidermis that always studied. These cells have certain specialities. They become large, empty, colorless cells. And these cells are called bulliform cells or motor cell, important for exam theory entrance. And normally that occurs in bundles or groups. And their function is helps in lengthwise curling or rolling of leaves to preserve water. And this action is connected with the turgidity and flaccidity of the cells. So the water available, water not available, based on it, rolling and unrolling takes place. So flaccidity of the cell, Substomatal cavity is connected with the stomata. Now the photosynthetic area as usual, mesophyll, present between upper and lower epidermis. Here we cannot observe separate palisade and spongy tissue. Since it is monocot, here we can find. Shape of the cells are more towards spherical, somewhat more closely packed and irregularly arranged. This area is for the site of photosynthesis. Now comes the last part in monocot leaf, vascular bundles. It will be many. Each bundle is surrounded by a bundle sheath, a layer of thin walled cells. Vascular bundles are conjoined closed, no cambium in both the leaves. Xylem is on the upper side, adaxial. Phloem is on the lower side, that is abaxial. And near similar size of vascular bundles are seen, except in main veins, in monocot leaf connected to the parallel venation. NCERT, that statement. Then as usual, 5 theory question, 5 NEET model question with the key. So what all things we learned in this episode? That is the last part of anatomy of flowering plants. That is 5th one. Mainly dicot stem, monocot stem, dicot leaf, monocot leaf, their sections. So we can proceed. So when we start with the dicot stem, epidermis will be there. Structures and trichomes will be there, cutically seen single layered. Then cortex, many layered. Then seen between epidermis and pericycle, 3 subdivisions of cortex, hypodermis, 3 to 5 layered, colon chimatas, no gaps, angles are taken. Provide mechanical strength as usual. Then comes after hypodermis, next is general cortex. Below hypodermis and above endodermis, the involved parenchyma, interstellar space. Endodermis, innermost layer of cortex, can have starch grains or starch sheath. Then comes pericycle, below endodermis, above phloem, patches it occurs, sclerenchymatous. Vascular bundles, many, consist of xylem, phloem, cambium, conjoined, collateral open, stem and dark. Vascular bundles arranged in a ring. Then comes the central part, pith or medulla, parenchymatous, interstellar spaces, then pith rays or middle rays also can be seen for radial conduction. Now comes monocot stem. As usual, epidermis, single layered, cuticle present, stomata may be seen. Hypodermis is sclerenchymatous. Dicot it was collenchymatous. Monocot it is sclerenchymatous. Monocot stem. Ground tissue, it is the main bulk, not differentiated just like dicots. Dicot more differentiated. Below hypodermis, parenchyma cell mainly seen. Then vascular bundle, large number of vascular bundles we can find. It is scattered. Then size of the vascular bundle small and more towards periphery in this diagram you can find. And larger and more freely arranged towards the center. Cambium absent. Then each vascular bundle is surrounded by a sheath called bundle sheath made up of sclerenchyma. No cambium, close conjoined, no secondary group. Xylem is centered. Presence of water-containing cavities found by schizolysigenous in origin. And protocell and lacuna we can find. Monocot, phloem parenchyma is absent. Now comes leaves. Dicot and monocot leaf. Leaves are the main photosynthetic organs, flat. Epidermis will be there, upper and lower. Then photosynthetic tissue, that is mesophyll. Then to TS, dicot and monocot leaf. Dicot is dorsiventral, monocot is isobilateral. Then comes upper adaxial ventral, all are same, synonym, top side. Lower abaxial dorsal, all are same, underside of the leaf. Dicot leaf generally remains horizontal, by which sunlight falls on upper epidermis, upper surface. And in dicot leaf, dorsal ventral side are very clear. Monocot leaf generally remains vertical. Both surfaces of monocot leaf almost same, isobilateral. Then dicot leaf, we can find epidermis, mesophyll vascular system. Upper and lower epidermis, vertical person, single layered, parenchymatous, less stomata on adaxial epidermis, maybe on absent in comparison with the lower epidermis. Lower epidermis more stomata. Then substomatal cavity can be seen, connected to the exchange of gases. After that, no chloroplast in epidermal cell. Guard cells may possess, but generally epidermal cell lacks it. Cuticle present. Now comes mesophyll. It is the main photosynthetic area, mesophyll. Then lying between upper and lower epidermis, it is a part of ground of fundamental tissue system made up of parenchyma with the chloroplast involved. Then in dicot leaf, 2 regions for mesophyll, palisade and spongy. Palisade below upper epidermis adaxial, 1 to 2 layered. Cells will be vertically arranged. Cells are elongated. Cells are parallelly placed. Numerous chloroplasts, no interstellar space. Then spongy parenchyma below palisade tissue, lower part of mesophyll, abaxial, round or oval cells. Irregularly placed cells have interstellar space, air cavities, chloroplast seen. Now comes vascular tissue system. In vascular tissue system, we can find vascular bundles are scattered in spongy area. It can be seen on veins and midrib of the leaf. Venation reticulate, thickness of the veins will vary. Vascular bundle have no cameo, so it is closed, conjoined. Vascular bundle is surrounded by thick wall bundle sheath. That is what NCERT says, thick wall. Vein number 77, connected with the figure 6.5, representation March 24. Vascular bundles are larger in thicker area, smaller in thin area. That is thicker veins and thin veins. In leaf, xylem is adaxial, upper, phloem is abaxial. Just like our face, eyes are xylem, mouth is phloem. That way you can remember. Now comes monocot leaf, isobilateral leaf. Or some features will be common, some will be different. So here also epidermis, upper and lower epidermis, single layer stomata present. Number of stomata almost same on both sides, cuticle present. Then presence of certain large cells or upper epidermis. These cells are called bulliform cells or motor cells. They will be large, empty, colorless, causing lengthwise curling of a leaf connected with the turgidity and flacidity of the cell. Then sections we can find, 2 sections will be given again. Then next is mesophyll, present between upper and lower epidermis. No distinction between palisade and spongy. Shape of the cells are more towards spherical, closely packed somewhat, regularly arranged, site of photosynthesis. Vascular bundles, many, each bundle is surrounded by bundle sheath, a layer of thin-walled cells. Vascular bundles conjoined close. Xylem is adaxial, upper, phloem is abaxial, lower. Near similar size of vascular bundles are seen in, except in main veins. Monocot leaf is connected to parallel venation. It's almost similar size of vascular bundle, except in main veins. Monocot leaf is connected to the parallel venation. That is how the arrangement of vascular bundle comes. Then as usual, 5 theory question, 5 NEET model question with the key. By which this anatomy part is getting over. Now we have 3 more chapters that will be continuing: morphology, bioclassification, cell. So hoping that it is clear to all of you. If you like this episode, subscribe all, like it, share it, comment on it. We can meet later. Thank you. Take care.